All right, so if you didn't watch the previous video, make sure you watch that. That's where we got all of this information, A, B, C, D, E, F, and G. We took this function and we figured out all of this information about it. So the first thing that we figured out is that the domain of the function goes from negative infinity to -1, and then it doesn't exist at -1, so I'm going to make sure that I use that piece of information here to put a -1 on my graph. Then it goes from -1 to 1, so I got to have a 1 on my graph, and then it goes towards infinity. So this is our domain. Got to make sure that we've got the points where it doesn't exist there. All right, then B, where are my intercepts? We determined that this function has an x-intercept at 0 and a y-intercept at 0, and that is at the point 0, 0. So I'm going to plot that point on my graph. All right. Then C, determined that this is an even function, which is pretty great because now I can really just sketch 1/2 of my function and then reflect it all over the y-axis. So I'm just going to really focus on sketching the right half of this function and then making the left half look exactly the same because we proved that it's an even function. D asked for asymptotes. So we found that it has a horizontal asymptote at y equals 2. So let me go ahead and label this as y equals 2. And I'm going to sketch that in using a dashed line here. All right, so that's a horizontal asymptote. And then I've got these two vertical asymptotes as well, one at x equals 1 and another at x equals -1. All right. Now we're going to talk about where our function is increasing and where our function is decreasing. So we know that from -infinity to -1, our function is increasing. And since x equals 1 is a vertical asymptote, our function must be doing this, right? So if it's doing that on the left side, then it must be doing this on the right side because it's even. Let's just check and make sure that that checks out. So that would mean that our function has to be decreasing from 1 to infinity. And we did find that our function is decreasing from 1 to infinity. So I'm going to sketch in what my function is doing there. So we've got a horizontal asymptote and we've got a vertical asymptote. So our function must be doing something like that. And we decided that over here, it's got to be doing the same thing. And it's approaching those asymptotes, but never reaching them. Now we've also got from 0 to 1 and from -1 to 0 to discuss. So this says that our function is increasing between -1 and 0. So our function is going up that whole time, right? But we've got to take some other things into consideration here. We got to figure out if it's going up, 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 when does it stop and come back down? We figured out that it's got a local maximum at 0, 0. So that must mean that our function is increasing until 0, 0. And then it says it's decreasing from 0 to 1. So it must be going down after that. Okay. So let's sketch in that our function is increasing till 0, 0, and then it's decreasing from that point on. And lastly, we're going to make sure that this checks out with the concavity of the function, and we will see some functions where there will still be some unknowns that we'll have to figure out with g, but at this point we're just checking to make sure that what we confirmed with g is correct. It's got to be concave up from -infinity to -1, and that is true. Our function is concave up there. It's also got to be concave up from 1 to infinity. That's true. And it's got to be concave down from -1 to 1, and that's true as well. So this is what our function must look like. And we're going to practice doing a lot more examples like this in class, but the one that you're going to do today is example 2 from the textbook, so make sure that you do that on your own, and then we will check it together and continue doing some more different examples on Monday.